The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be starting SolidCAM Live today. So half-hour free training session that we're doing during this pandemic period. Right now we're planning on doing it until May 1st, but if there's demand or if the situation continues, unfortunately, then we'll continue. We'll start today's class. With me as always, I have Kevin. Kevin, you there?
Hey guys.
Hey Kevin. So we didn't receive any questions from yesterday, and I don't think there were too many or any lingering questions from last class. So we'll just start with a new set of questions. So what I was thinking we'd cover today, a question we get a lot on the tech support side and the training side is coordinate systems. How to set up coordinate systems, what are the different options, if you had a fourth axis part, that sort of thing. And I've got the same part from the other couple days, only in case we had some questions, but we can also go to a turning part to help out with that as well in terms of coordinate systems. But basically, coordinate systems, if we go to the coordinate system manager, you can set up your coordinate systems either at the beginning of your part file when you're inside of the CAM part directory, when you're actually playing with the stock, target, all that stuff, or as you go along, like I did here, we can always return to the coordinate system manager and add your coordinate systems. So if you happen to have an idea of what you want to do up front in terms of coordinate systems, you can put them all in at once. If you want to do your side one, get all that stuff done, and then figure out how you want to set up your side two, then you can always come back and set up your side two, your Mac 2 position 1. So we'll talk about this one window here just to start. Mac 1, Mac 2, Mac 3, all the way up until as many as you have on your machine. Those are actually the offsets on your machine. So Mac 1 on this machine would be my G54. My Mac 2 is my G55, and so forth. So inside the software, it's called Mac 1. In the posted code, it could be G54, it could be P1, E1, whatever it is on your machine. The position is an indexed position off of that. So on a fourth axis machine, maybe 3 plus 1, or a mil-term machine, Mac 1 position 2, Mac 1 position 3, those are just indexes off of that original one. So you'll still use the same origin in the posted code, but you're just going to give it a different angle. So that would be, you know, an A angle, so A90, or if it's a C angle, C90, whatever it is on your machine, whatever your setup is, your index position, really the way you're going to set that up is you're just telling it what angle to be off of the origin, and the angle is actually going to be set by the Z axis, because in all coordinate systems, your Z axis is your tool axis, milling or turning. So let's take a look at how you actually set up a coordinate system for a milled part. So I'm just going to add a new one. So we'll just say add. And this one defaulted to Mac 1 position 2, but if we take a look at my post, it's probably just a 3-axis post. So this actually should default to Mac 3 position 1, meaning the third offset on my machine. What you're going to do to set up your coordinate system is choose one of these 5 options. A lot of people, they see the 5 options here and they think it's something like you choose the face, and then you do define, and then you choose points. You choose one of these options. It's very similar to what you do when you do the stock or target definition. There's multiple options, but you really just choose one of them, and then you use that to set up your coordinate system. And really how you choose which one, how you decide which one to choose is the geometry you have on screen. So for instance, we have a solid here. We're going to use the faces of the solid. So select face is the one I would probably use. But for the other ones are more for when you have very simple geometry, or maybe you have a solid but has no flat faces, no sharp edges. You're still trying to get your origin, your x-axis, and your y-axis. So let's say we start from the bottom here. By 3 points associative is literally if I only have points to choose from. It could be from either a print, like a DWG file or a DXF file that I've translated into SOLIDWORKS geometry, or it could be a solid that has no sharp edges, no flat faces, no straight lines. It's all just pure vertices. Or maybe you've translated an STL file, something like that. With the by 3 points associative, you start by choosing a vertice or a point that represents the origin. So let's say we do it on this guy here. So I'm just going to choose that point there. Next, it's asking me for the X direction. Now this would be the X positive direction. So I choose a point in the X positive direction. That's this guy right here. And you can see it adds the X axis. Now let's go over here and we'll just choose a point in the Y direction. So we'll just choose that point over there. It gives me Y. And because of the right hand rule, as soon as I have X and I have Y, I have Z. So there's my coordinate system right there. And that sets it up as Mac. Actually, it looks like I guess I have a multi-axis tool coordinate system set up. Should have been Mac 3 position 1, but basically per your post processor, it'll tell you what you're actually able to make there. So this could have been Mac 3 position 1, this could have been our Mac 1 position 2 at a different angle. Essentially what you're doing here is just setting up your origin, your coordinate system for whatever it is you're setting up here. Let's jump out of here. We'll jump back in again. And this time I'll just actually label it Mac 3. So let's say we're actually making that separate setup. By 3-point associative uses points. Let's say you had some sharp edges, some straight lines. We can go to define, and it's very similar. We'll choose a point that represents our origin. So I'll just hover over that until I see that point symbol. So there's my origin. A line or a point in the x direction. So we'll just say that line right there. And now my x-axis is parallel to that line. And let's just go down here and I'll choose a line in the y direction. Or that actually is grabbing the point. So let me just reselect that. Let me try and get that vertex there. There it is. So x and y gives me z. So same as before. You choose the geometry that's on screen. So if you had some straight line edges of your part, of your solid, or of your surfaces, or if you just have a point cloud, you can select those. The other two ones on this list are actually a little simpler than even those. Select coordinate system actually is looking for a coordinate system that came in from the SolidWorks side. So because we're integrated inside SolidWorks, and because you're either bringing in a design model from SolidWorks, or in this case here, you can see it's actually grabbing a coordinate system from my Vice model that I brought in. That is a list of the SolidWorks coordinate systems that were imported with the solids. So if on the SolidWorks side, I had designed or assigned a coordinate system inside SolidWorks using the SolidWorks coordinate system functionality, then I could just come in here and translate that into a SolidCAM coordinate system. Because always remember, the SolidWorks coordinate system is going to be different than your SolidCAM coordinate system. Once you're inside SolidCAM, all your references, all your measurements are coming from your SolidCAM coordinate system, your Mac 1 position 1, your Mac 2 position 1. So that's really simple. You just click on that, shows us a list of SolidWorks coordinate systems, and then you just choose which one you'd like to translate. Normal to current view, this is more for multi-axis work. Let's say we had a multi-axis part here, and I know that maybe there's some sort of hole or I need to kind of come in at a different angle to do an indexing, to kind of do something on this side. And I don't know what actual angle I need to come at. So I can't really use the rotate by, modify by rotation or any of this stuff down here. Well, I can just kind of eyeball it with my mouse. And then when I click on this button, it takes a snapshot. And it'll actually use the same origin as the original origin. So in this case, let's say we were setting up a Mac 1 position 3. That would use the coordinate system, that would use the origin of Mac 1 position 1. So under Mac 1 position 3, it's an indexed angle. I'm eyeballing it here. I click on that button to get the snapshot. Now I'm using the origin for Mac 1 position 1. I've got the x-axis going positive to the right of my screen. I've got the y-axis going positive to the top of my screen. And the z-axis is my point of view. That's why I eyeballed it like this. So the z-axis being your tool axis, now I'm telling the tool, come from this angle and approach the part. And that's just normal to current view, really useful for simultaneous 5-axis or even indexed 5-axis, because if you're not really sure what angle to come from when you're doing an index toolpath, this is really easy. But the one that's most common is select face. And that's because most commonly you're probably using a solid. Now with select face, what you're actually doing is you're just choosing a flat horizontal face to orient to that z-axis. Because remember, z-axis is our tool axis. So in the case of this part, I want to do these pockets, I want to do some of these surfaces, and I want the tool to come from this direction. So I'll just choose a flat face on the part to orient my z-axis to come from that direction. And it doesn't necessarily have to be the top face of the part. It could be any horizontal face that orients the tool. Let's say this part here got a lot of curved surfaces on it. It does have a few flat surfaces, but I'm not really looking for those surfaces. Let's say all of these were curved. I can still click on any flat face of any solid on my part just to orient my z-axis. But let's say we do it on the part, just for example. So I'm going to click on this face here, because what that does is it gives us the minimum extents box of that solid. All the outside edges, even if this was a circular part, it would actually give me all the tangential edges of the part. And this is just the maximum limits, maximum envelope of that part, because now that allows me to move my origin around if I need to. A lot of people think that this is the stock. This is not the stock. Your stock might be the same shape and size as that, but you're not defining the stock at this point. What you're actually doing is just giving yourself some rectangular options here to move your origin around. And since these all represent the outside edges and center of each edge and center of each face of that box, you really have a lot of options here to move your coordinate system around. For instance, let's say, since I had it set to top corner of model box, but that wasn't the corner that I was intending. Maybe I meant this corner over here. I can click on pick origin, move it over there, and now my origin is shifted over there. Let's say there was something on my part that I want to, let's say this right here, this circle, the center of the circle somehow represents where I'd like to set up my origin. If I use pick origin, it's going to move my z equals 0 to that plane as well, but that's not what I'm intending. I'm actually intending just to shift it in x and y. Well, that's what this pick xy origin is all about. It's just going to shift it in my current xy plane. So if I click on that point there, it actually shifts it so that x and y 0 are on that point, but it just shifted it in the xy plane. Z is still at the top of the part. Okay. Pick x direction, pick y direction. This is very similar to what we did with define, but in this case, though, we already have an origin. So if I just need to get my x, let's say to be, let's say I want to be a little askew and I want my x to point in this direction over here. I'm just going to pick a point at random, maybe this one here. And now my x points at that point, meaning that my x-axis is now in that direction. And you can do the same with y. The reason these are useful is sometimes you can choose the top corner model box, you can choose the z level correct, but maybe your part is askew. Maybe your part is on an angle. And that does tend to happen when parts are designed in assembly inside SolidWorks, because maybe the normal directions, the 90-degree directions, the x and the y directions from your SolidWorks part or your assembly are not how you designed it. Maybe you did a circle on a weird angle, or your cube on a different angle. Whatever it is about your part, it could be what we call askew. To correct it, when you get inside SolidCAM, is to use these pick X direction, pick Y direction, because then you can actually tell it what the new X-axis, the new Y-axis are. And then once you do your programming, those will be the proper directions. Nothing is askew anymore. So that's what the whole point of this section is all about. But let me get back to this window here. So you're choosing a face to orient your Z-axis, but the face you choose doesn't necessarily mean the top face. It could be the bottom face of the part. So if you choose, let's say for instance, I want the origin to be at the bottom of my part, I can still choose the top face. Let's just go to bottom corner of model box. If I want my origin to be at the bottom of the part, I still choose the top face like I do here. Let me just jump out, jump back in to reinitialize that. And I do see there's some questions. I just want to get through this quick, and then we can get to those questions. Okay, so let's just make this Mac 3, position 1. Bottom corner model box, meaning that if this is the top face of the part, then the bottom of the part, bottom of the solid, is down there. And then that's the bottom corner. And again, if that's not the bottom corner I was talking about, then I could just click on pick origin and move it over there. So this is really just to place the origin relative to whatever face I've selected. So you have options like top corner, top center, bottom center, and you've got the other ones there as well. Now, basically what you're doing is just setting up your origin. But let's say you had a circular part, like you're going to put it on a turn part. On a lathe, yeah, there you go. The word escaped me for a second. You can use center of revolution face, and that means any revolved face on the part. This could be a part like this where maybe we want to locate off of this guy here. So I wanted maybe the center of that boss there. That's pretty circular. You can see that it places the Z-axis as dead center of that circle, of that revolved face. On a lathe or a mill turn, you would use this to set up your Mac 1 position 1 for turning, because in that case, on a lathe or a mill turn, your Z-axis is your rotary axis. On a 3+1 machine, your X-axis might be your rotary axis. In that case, you'll use some of the other options down here, and that's kind of a good segue to get down here. Let's say that I wanted the origin maybe to be dead center of that, but I need my Z to point towards this direction. Maybe I'm doing some sort of 5-axis move where I want to use the side of the tool along there. So I need Z to point in that direction. Well, to start, I could have actually chose this flat face, and it would have oriented my Z-axis perpendicular to that face. But let's say some of this geometry was a little easier to use in this case. Now I have this origin here, but I still need Z to point in that direction. I can do a flip around Y, and that flips the XZ plane around the Y-axis. So now Z is pointing in this direction. If I do a flip around X, it flips the YZ plane around X as a rotary. And with each click, it's 90 degrees. Okay. So you got all of these here to do the flips, and then down here you have modify by delta and modify by rotation. Again, the idea is you start with what geometry you have on screen, you start with the setup you have on screen, and then you shift it to match what you're looking for. So in the case of the original coordinate system, let me just put this guy back facing upwards. So let's say I wanted it to be centered on that boss, but I actually wanted it to be representative of the stock. I want to be maybe 50 thou above the top of the part. I could come by to modify by delta in the Z direction, change it to 50 thou. I'm actually going to put that at a larger number so we can actually see it shift. So let's make it 1 inch. You can see now that it's 1 inch above the part. If we know that it's a skew or there's something about this where, however I have this set up, it should be at a different angle, that's modify by rotation. So let's say we wanted to rotate around the Z-axis by 45.
And this modify by rotation really helps out if you guys are running on a 3-axis mill and you're using a sign plate that's angled for 30 degrees to do a certain work. This is where you can go in there and type in that angle of that sign plate too.
Exactly, kind of like that. So this is the opposite what I was talking about with that normal to current view option. This is when you actually know what angle to put it at. So like Kevin said, a sign plate or any other work fixture where you know what angle the Z needs to be put at. So let's say if this thing was on a sign plate of 60 degrees, Z could be pointing up that way, and this thing is now angled appropriately.
Now, Mark,
so
let me ask. Oh, go ahead.
No, go ahead. I was just going to move on to the transform, but
let me ask you this: can we put our coordinate system on a vise or a fixture?
Yes, absolutely. So any geometry on screen you can use for these options here. So like you saw me do a second ago, let's say this part there's no flat faces or anything like that, but we're not even going to touch off on the part. Maybe we want to touch off on the vise. You can still use let's do top corner model box on any face of any solid or any surface really inside the software, inside your setup here.
And this makes it really handy, like what Mark's saying, if you have nowhere to probe. I know at my previous job, we had a probe, we would stick in dowel pins or do dowel holes. So the probe could go in there, probe it for the X, Y, and Z for that hole, even though that part wasn't even near that. So definitely use that to your advantage as well.
Absolutely. Use what you have in front of you, basically. Now, the challenge with that, though, is because this is based off of the solid that I selected, you can see that the minimum extents box is looking at the part from that vise assembly and not my actual solid. So what you want to do in this case is once you accept that location as your origin, you want to come here and actually play with these levels here. So the part upper level is not actually 0 because that's this face. You want to set it on the top of your part. So let's say part upper level, we'll click on that and we'll click there. So now that is the proper part upper level. And then the part lower level, same thing. If it matters for your toolpath, that's the part lower level right there. And then because of that, you want to make sure that these clearance level, tool start level, and the Z level are matching that because these are default values. They generate 1 inch, 5 inch, and 10 inches above whatever the part level is when you first clicked on that solid for the coordinate system. So in this case, 1 inch above that is incorrect now. So we just need to correct it so that it's actually, if we want to keep 1 inch, just 1 inch above whatever our part upper level is. So in this case, we can say this is 2.755. And then 5 inches above that would be 6.755. So basically, that's what you want to look at when you set up your coordinate system with the origin a little further inside your part. And that also is important for your index positions as well. If we have an index position where, like we originally had it at 60 degrees in this direction, my part upper level should now be this point here. Part lower level should be this over here. And I should take all my clearance level and tool start level from here. It should go out from here. Because if my origin was maybe sharing the same origin, let's do it like this. If I shared the same origin from Mach 3 position 1, when I made my Mach 3 position 2 on this angle, that's my part upper level, that's my part lower level, and my clearances should be taken from there. Otherwise, 1 inch and 5 inches above 0, it's probably somewhere over here. So whenever you do index position, you want to, or this sort of recessed position over here, always keep track of your levels because you can get a crash in that case. Okay, so finishing up talking about coordinate systems, let's just get out of here, is the idea that if you want to make multiple, let's say you had all 10 parts you have to make, set up in 10 different vices, there's actually a transform command inside of this window. If I just right click on the position, I can go transform copies, and it works very similar to the transform command inside the actual operation structure, where you can do a translate and a fourth axis. So again, if you're making multiple copies and you need multiple coordinate systems, you can do a translate and a fourth axis transform. It works very similar to the same transform command you find inside the software. Okay, and then one last thing. I know I keep saying one last thing, but coordinate systems is actually a really large topic, but I want to make sure we get to your questions today, or at least record the questions for the future. You always want to make sure that you add a machine setup so that you tell SolidCAM which coordinate system you're working under. And every time you change coordinate systems, in the case here, let's say when I go to do my side 2, I guess I didn't add it in here, but you want to add a machine setup at the end of all your operations. So let's say at the end of these operations here, I'm going to go to machine setup, I'll put it after, and in this one, I'll tell it that I'm working under the Mach 2 position 1. So anytime you change coordinate system, you need to add a machine setup, like so. And then I can put all my Mach 2 operations under this.
Mark, go ahead and open up that coordinate system manager again for us. So as it sits right now, Mach 1 by default is going to be your G54. Your Mach 2 is going to be your G55. Mach 3 is going to be your G56. But happens quite often is maybe you guys want those to be all G56. You want to show them how to do that? Easy as that.
In the newer posts, it's pretty simple like that. You just put it in what you want it to be called. So if I want to automatically jump to G56 and I want my side 2 to be G56 as well, then you just relabel it. And to know if you can just do it like that, you can always go to your CAM part. And like I said, in the newer posts, that's automatically done for you. But some of the older posts, you'll have to go over here to where it says, I work offset method. Just change that from a 0 to a 1. Basically, 0 is this option is off. 1 means it's turned on. So what happens is, with that turned on, and it just lets me know that I'm making a little bit of change there, that's fine. Okay, and I'm just gonna post something that's fast. Let's say we just post this guy real quick here. So that is under Mach 1 position 1, but it outputs as G56.
So an easy way for you guys to go through and customize your work offsets. So you don't have to have them right in order. Just go in there and type in what work offset that's in there. And it will automatically add in there a 1 dash, whatever you type in there. But when you go to type that in there, just tell it what work offset. Don't put in G56, just type in 56.
Okay, so that's it on coordinate systems. I mean, like I said, there is actually a lot more we can cover there, more detail, but as a primer, that's pretty good. Let's get to the questions, just so we don't miss them.
For Frank's first one, we can maybe touch on that at the end. And then what Jake was getting when you were doing your 3 points, you can actually do that off of sketches as well. So if you guys are trying to create a coordinate system in a specific way, you guys can create those sketch points or sketch lines inside SolidWorks and use that as your reference geometry as well.
Absolutely. Like I said, these options here are based off whatever geometry you have on screen. It doesn't necessarily have to be a solid or surfaces. So like Kevin was saying, it could be sketch points or it could be the vertices of your solid. And that's the same for both define as and 3 points. Pretty much any vertice, any sketch point can be used.
Yep, absolutely.
Okay, so looking at Charles's question there.
Not sure what.
Okay, so let me read it out here. So whenever I try to place an origin on a face of an angled surface, I cannot seem to figure out how to place the origin on the face versus top of the rotated part or on coordinate system number 1. Is there a way to set that without modifying a known number? Not sure what you mean by modifying a known number, but probably, you know what you could do, Charles? At the end of the session, I give you guys my email. If you have a part that you have trouble with, what you could do is like delta mod. Okay, so you're referring to, let's just get a nice flat face here. You're talking about down here? Using these modifications down here? Yeah, okay, so I think I know what your question is. If you don't know what number to actually rotate it at, that's kind of the normal to current view if you could eyeball it, or if you actually need to get, like let's say you actually have some faces and you need to orient it a certain way, like if you did choose that angled face. It's all based off geometry. So if you don't know it from, let's say, the print or something like that, you can do some SolidWorks sketching to get your values there. If you know, for instance, let's say on a part like this, I only had this flat face here, but I don't know what angle that's at. I could measure it by actually measuring the edges. I can measure it maybe going from one face to another, or I could actually maybe make a sketch on this face, start a line that goes from that vertice up just freehand, and then using the SolidWorks sketch controls where you can do constraints, set that line to be perpendicular to this face or another face or some sort of other reference. And then you can actually just get your straight line. And then like Kevin said, with sketches, you can create your coordinate systems that way as well. So if you don't really know what angle to put it at, the geometry should give you that idea. You should be able to find something in your model, in your sketches, whatever you've got available to you to find what angle to place that at. Does that answer your question, Charles? Yeah, okay, perfect. Okay, so Jake's question, what are the radial and levels rear? Okay, so let's say we accept what I've done here. Really simple answer is when you're doing a milled part and you've got a coordinate system that is telling you levels on a milled part like this, it's planar. Whenever you're looking at a revolved part, like when you're doing turning or mill turn or anything like that, look at the radial values, because then you'll actually see your z-axis is your rotary axis, so you're actually looking for the radial limits off of that, so actually kind of like the x-axis direction. So that's radial. And rear, I believe that is kind of the same thing. I'm not sure. What do you know what that is, Kevin?
That one is one that I don't ever use, so it's hard. The only thing I can really think of for you, Jake, on the rear levels is going to be for multi parts. So when you get into the Swiss type or multiple spindles on your lathe or mill turn, this is where you'll have your levels radial, and then you can also set up your rear levels as well in there. But like I said, that one is one that does not get used very often at all, and especially if you guys are just working in milling. But if you are working in a multi-spindle machine, that is where you can set up the rear levels. So basically 2 parts.
Okay.
But usually when you guys are running 2 different parts on something like that, you would have 2 different coordinate systems to go along with that. So.
Okay. And then Jake's comment of he's never had to change those values. Chances are, if you're using the select face option, you're never really changing these values either,
Yep.
because they're generated for you off of the upper level, lower level of your stock solid. But you do sometimes want to make sure you change these, like I said, when you're doing index positions, or if you're doing any kind of 5-axis work, or if you're going maybe from one part to another, or there's some sort of height difference. I literally just finished doing this for a customer where you want to look at these levels as well, because if you're going from one part to another, maybe when it goes to, let's say, from one corner system to another, and there's a height difference, the z equals 3.5 is different from corner system to corner system. It might actually cause crash. So you want to make sure that you retract further from one corner system to another, that sort of thing. So these levels you usually skip over because it's pretty simple to do that. But if you're doing anything where there's a difference or an angle difference or anything, sometimes you want to look at this and keep track of that. Okay, so I think, yeah, okay, so I guess we'll go back to, actually, one more question. Well, levels planar is anything with milling, but yes, sometimes if you choose your origin off of the stock, but you need your z equals 0 to be on the top of the part, then that's when I would say choose the part.
Yeah, and kind of what I think what Jake's going for is, on your stock, and technically you cannot create a stock until you have a coordinate system. So if you guys are wanting to go off of your actual stock model instead, go ahead and just create a dummy coordinate system first. Then once you have that coordinate system on there, put your stock on there, accept that, and then what you can do is you can go off of that for your stock, go back in and repick your coordinate system again. So just put a dummy one on there just to get it in there real quick, and then, like I said, put your stock on there, and then you can do it based off of your stock.
Yeah. So you really, like Kevin's saying, let me just get to this window here. This is the first window you see when you first open up your part, the CAM part definition. To get out of this window, you just need to choose your post and a coordinate system. So like Kevin said, just add a dummy coordinate system, then click the green check mark, bring in that 3D model solid, made it up correctly, assemble it, whatever you need to do. And then when you come back in here, then you can go and reassign your coordinate system to the new solid you have on screen. It's all about what coordinate system, what geometry you have on screen at the time of the creation of the coordinate system. So you can always come back and reassign that coordinate system. Yep. Okay, so that is, all right, so we've got a little bit over time, but I want to see what Frank's question was, just so we can make sure we either address it now or tomorrow.
So Frank,
how do you define?
Oh, go ahead.
I was going to read it so that everybody can see. I'm not sure if everybody can see it. How do you define a chamfer tool that does not come to a point? I use a taper mill with a 45 degrees, and it seemed to work. Is that the correct way? Essentially, in my opinion, yeah, it's either a taper mill or a single point chamfer tool. What do you think, Kevin?
Yep, I would definitely do it as a taper mill because, Mark, if you want to open up your tools and add in a taper tool there, with a chamfer tool, it comes right to a point where with a taper, you can set up what that tip diameter is down there, and then it will auto-calculate for your machine as well as your presetter, so everything is coming out correctly. Some guys try to cheat it a little bit and just do a spot drill, but you're kind of playing with the fire there just because you're kind of guessing at that point, because at that it's a theoretical point. So
absolutely, yeah. And I was going to point out that when you use a taper mill or a chamfer mill, whether it comes to a point or has that tip diameter, when you come in here, you program it the same way for your chamfering. You give it the cutting diameter. So if you have a taper mill and it has a tip diameter, just make sure that this value is larger than that tip diameter. If it comes to a single point, it's still looking at the angle of the tip, the angle of that cone shape, and it's finding the cutting diameter along that mathematical cone. So if it comes to a point or it actually is a trimmed cone and has a tip diameter, this setup here for your chamfering, it doesn't matter. It still looks at just where along that mathematical cone that diameter sits, that height.
Perfect. And hopefully, does that answer your question there, Frank? Okay, perfect.
Great, great. Okay. And if you would like to see that, let us know, and we can always do chamfering with different tools or whatever shape tool you're actually looking at. We can always do that as another option. I'm going to give you guys my email.
And while Mark is typing that in there, I'm going to ask everyone in here, because we have quite a few people in here, shape tools, but more or less a corner round tool. So if we wanted to add a corner round tool in there, is that something that you guys would like to see maybe for tomorrow? Yep. Okay.
All right. So there we go. We got tomorrow's topic.
We'll plan on tomorrow, just because, thank you, Frank, for that question, and we'll kind of stem off that a little bit. So it is not a tool that is in there, but tomorrow in the SolidCAM Live, we will show you guys how to create that and how quick and easy it actually is to create that in there as well. So.
Okay, great. Okay, so if you have any other questions, or if you have a part that we can share with the group, remember this goes on YouTube, so any part we can share to the world that comes on to the SolidCAM University channel, go ahead and send it to me at my email there. I put it in the chat section. Any questions, any topics, anything you'd like to see here, you can also use that email to email me directly for training. This is a half-hour version of the kind of paid training that we provide to our customers. If you're interested in training, contact your local salesperson. Either you already have online hours purchased as part of your last purchase of your upgrade or your software, or if not, you can always purchase hours from your local guy, and then you get one-on-one with me, Kevin, Greg, rest of the guys on the team. We're all the trainers for SolidCAM, so we can get online with a go-to meeting similar to this. Take a look at your parts, cover questions you have, and it's live. So you can actually ask questions, not like this kind of text system, but actually live with your voice. So if that's of interest to you, go ahead and email me for scheduling. Other than that, we will talk to you guys tomorrow at 2 p.m. Eastern Time. Like I said, we're doing this up until the end of the month, and we'll see you guys tomorrow. Stay safe. Keep your family safe. Talk to you tomorrow.
All right. Thanks, guys. Have a great day.